we have a distinguished seminar from Dr. Iman, and I briefly explained his biography. And yeah, it is really my honor and pleasure to invite him to POSTEC. This is the first time he visited POSTEC. Okay, so Dr. Si Moan is currently distinguished visiting professor at Tsinghua University, visiting researcher at Google, a member of the inaugural board of governors of the State University, Calcutta, and the advisor of the Calcutta Blockchain Academy and the Dewey government agency in India. He retired in June 2020 after serving as a IBM fellow for almost 30 years in the database and blockchain and AI-based areas. And he is a very well-known researcher for inventing the well-known areas family of database locking and the recovery algorithm. So I think that all of you are familiar with all those algorithms because I have taught in the class. And he was an IBM fellow from 1997 to 2020, and he is a ACM and IEEE fellow. And also he has served as IBM India chief scientist, and he's received numerous awards, very prestigious awards, including ACM Sigma Edgar F. Top Innovation Award in 1996, and he's the fifth winner of that award, right?
Yeah.
And he also received the VLDB 10-year Best Paper Award in 1999, and many numerous IBM awards. So if you are interested in more about his biography, you can type C Moan at Google, and you can easily find his biography there. And so please join me to welcome Dr. Si Moan. Moan is.
Thank you. Thank you so much for that nice introduction, Bhushan. And I've known him for a long time. He spent a couple of years or 1 year in 1 year in IBM. So it's been a couple of decades since he did that. Yeah, as was mentioned, this is my first time, not only in POSTEC, but in Pohang, and I haven't been in Korea since the VLDB in 2006 in Seoul, but I've been coming to Korea since 1991. So I have a lot of good friends in the country and also Koreans elsewhere. So you can look at the slides at that link that I have posted. I tried to post it on Facebook this morning, and for whatever reason, the Facebook algorithms decided this is more like spam or some such thing. So they haven't allowed it to be made visible. But if you go to my LinkedIn profile, you'll see a post about this. I have to now figure out how to make this post show up in Facebook. Pretty strange, whatever. But you'll also notice on the left side, you have that QR code, and that reflects the, that reflects this URL, where you'll find a lot of material that covers talks and interviews and all that over a number of years. I haven't yet populated with everything I've done before, for which material is available on the web in terms of PowerPoint slides and videos. In some cases, even papers that cover it. And I highly welcome you all to go look at it because there will be much more technical stuff over there. Of course, tomorrow I'm giving the cloud database systems talk, but more recently I've given a couple of times, once internally to Google and subsequently in Osaka just a few days ago, a talk on trends and directions in query processing and query optimization. So hopefully you will use that stuff. This is just showing you, we should remove this floating. Okay, now since I don't know Korean, which is the one I click, that one to make it disappear. Is that the one or?
Yeah.
Okay. Oh, okay. And this one, will it stay put? Or no, disappear, good. So these are a subset of the people who I have collaborated with in terms of actually doing technical work and writing papers, as well as others like Phil Bernstein and Theo Harder and Stonebreaker and Hector Garcia Molina and such people who have not necessarily written papers with, but have been well-wishers of mine. So it's a big group of people. The guy who first hired me as a consultant is this Microsoft fellow, Hanuma Kodavalla. Right after my retirement from IBM, I was hired by him for a few weeks. Currently, of course, I'm a consultant for Google, as was mentioned. So I, owe a lot to the accomplishments I have had, to the kinds of support and technical work that I've been that I've had the privilege of doing with these sorts of people. Let's see. Is it because I messed around with this? I know it's ready. Right, yeah, it's ready. Okay. This one. Oh, it's recorded. Okay, maybe I can stand here and do it. Okay. So, thank you. Be aware of some of these factoids. I tend to not be politically correct. I say things as they come to my mind and so on. I, of course, grew up in an environment where both in India and in the US, things were very different. So this is a whole life history of mine, right? From a technical and education perspective. So I've seen the good times and the bad times in IBM, economy, this, that. I've lived now almost 41 years in Silicon Valley. So I've even though I've never worked in startups and such, I've been highly exposed to startups and venture capitalists and the funding and all that stuff that goes on, as well as all the ups and downs, the dot-com boom, the dot-com bust, and various such cycles. AI has gone through multiple phases of being hyped up, not giving it up to the expectations, and then coming down. Some of you youngsters might think AI is some brand new thing. Guess what? It's even older than since I came to America, and I came to America 45 years ago. So even during my undergraduate days in IIT Madras, I was already tracking speech understanding and such things that went on at places like Carnegie Mellon. So I left India in '77, and I did go back in a sort of a longer term sense for a couple of years, working as the IBM India chief scientist. So I'm well aware of also, because of all my travels, the kinds of conditions that are very different between developing countries versus developed countries, and how people in society and all that think about careers and so on. And in a lot of these places, the Asian countries, in particular, if you're not a manager, they think that you haven't made it in life. This is the dumbest thing to do, to think that becoming a manager is somehow better than staying technical throughout your life. And I've stayed technical throughout my life. I've never been a manager in my 38 and a half years at IBM. Although, because I became an IBM fellow after about 15 years, that is an executive position without being a manager, right? And so the way I worked, I worried about not only how I'm viewed by people outside in terms of whether I'm doing useful stuff, important stuff or not, as well as having an impact on IBM's products and money making and so on. So I wanted the best of both worlds. Having impact on the rest of the world in terms of the research community and such, and even technologies that other companies make use of, but also make sure that the people who are paying my salary got some benefits out of my work. This is different from some of the product people who might be doing a lot of useful stuff for the company, but they are not necessarily having an impact on the external community in terms of, mentoring people or their ideas getting used by others or textbooks covering the material and things like that. Of course, what applied to me might not necessarily apply to you. So in that sense, your mileage might vary. So as an undergraduate, I didn't have the luxury of doing a bachelor's in computer science because at that time, nowhere in India was it possible to do an undergrad in computer science because the field was so new. But we did have master's and PhD programs in computer science. So I got lucky. The beginning of the second year of my 5 years bachelor's program as an undergraduate student in chemical engineering is when, for the first time, IIT Madras received a computer. And that happened to be a fairly high-end IBM mainframe, which was a gift from West Germany. And of course, that had 256K of memory. That was considered a lot of memory at that time, so much for big data and so on. But it meant that I had to use punch cards and, 7-8 hours turnaround time on things getting compiled and results being given to you. You guys are all in the world of luxury compared to that. It took a couple of years before that 256K became 512K. We still couldn't run an interactive operating system, which required a meg of memory. So I did a lot of things on my own because I couldn't, in a formal sense, take classes in computer science. Occasionally, I would sit in on some master's course, but informally, right? So I did a lot of studying on my own. And remember, there was no internet, nothing, no PDF. So I had to actually write to people in the US and other places, handwritten letters, put it in an envelope and get on the mailing list and receive technical papers in the form of actually, paper and envelopes and such, right? So I happened to actually be on the mailing list of IBM Research in San Jose, UC Berkeley, the Ingress project and the System R project and so on. And I was fairly well informed. So was I tracking things in many other fields within computer science. And I got involved in some professional society kinds of things and wrote some survey papers on operating system and database systems. So overall, my mind was all set to go to America and do a PhD in computer science. Although to begin with, I thought I would do a PhD in management science because I was using more application packages than hardcore, close to the operating system or the hardware kind of stuff. But this bug was found and nobody was fixing it. I decided to roll up my sleeve and go learn about at the machine language level how the simulation package interacts with the operating system and things like that. So that's when I said the macho thing to do is to do PhD in computer science and not all this fluffy application MIS kind of stuff. So some professors even sent me things like their students' PhD thesis and so on. But anyway, ultimately, on paper, since I didn't have any great accomplishments to show, I didn't get any assistantship. So I paid my own way, parents taking loan and this and that to get to America because I didn't get any financial assistantship. But luckily for me, within 10 days after reaching the US, once I met people and showed them that all that stuff I hand wrote and all that is not cooked up stuff, but they can see me and believe things. So much for in-person stuff being better than virtual stuff, right? No amount of virtual way of operating. And also those times I wasn't talking on the phone or video call or any of that, right? I was just merely handwriting stuff and putting it in the memo. But in person, you can convince people much more than you can do through other means, right? So, but the problem for me was getting a thesis topic where I finished my qualifiers and all that fast. So that's when I said maybe going somewhere else and doing internships might help. I did, being in, what is it? It was kind of, it's telling me I spent too much time on one slide, a couple of slides. Yeah. Is there a timer that you can disable? Anyway, so I spent time at the French Computer Science Research Institute called INRIA in Paris, summer of '79. And I was at a Institute for Nuclear Research in West Berlin, summer of '80. But ultimately, it's when Avi Silberschatz came to, okay, now again. Silberschatz came to Austin and I started working for him. That's how I got back into the database area after having spent some time with different advisors in between, trying to work on some other place. So it turned out, while my thesis itself was nothing exciting, it was to do with some theoretical kind of way of looking at non-two-phase locking protocols, which I was able to publish and all that and get some name and all that, but personally, it wasn't satisfactory because I didn't implement anything and it didn't go anywhere. Subsequently, other people didn't build on it and so on. So I was very unsatisfied with what I got to do as a PhD student. So I was eager to get into the real world and get to know about real systems and so on. So it's for this reason that I didn't even bother to apply to any academic institutions for a job. Even as a fallback position, I didn't do that. I only applied to industrial research kind of places. But this piece of work that I did, let's talk about as the last bullet, that helped me because that showed this critical analysis I did of a system that had been hyped up a lot by various people in Harvard and Computer Corporation of America and so on, where they published not only conference papers, journal papers. Christos Papadimitriou, Phil Bernstein, and so on, said this is the greatest thing since sliced bread. But I felt it all was very impractical, and so I wrote this piece of paper and I mailed it to people who I thought should be aware of it. And again, in those days, you had to physically mail these things, right? Not just do a blast on the computer by doing email, spamming of people. So that helped me in getting this job in a practical environment. Even the organization that I critiqued, CCA, they were eager to hire me, believe it or not, Computer Corporation of America in the Boston area. But in the end, when the offer came from IBM Research, that was the ultimate thing for me because birthplace of relational databases, SQL, CARD, and Don Chamberlain, and all these people are there. So it was an easy choice for me as to amongst the places that offered me jobs, which one to go to. And the project I joined was the RStar project, which was an extension of the original System R project in which SQL got developed to the distributed environment. So I joined the project midway through its lifespan. Ultimately, lots of people that worked on that project became IBM fellows. I effectively was a replacement for the kind of work that was done by Jim Gray, who had been a founding member of the project. The person who was the manager of the project, who founded the project, is Pat Selinger. She is considered the mother of cost-based query optimization. She was part of the System R project. And so I'm forever grateful to the fact that she took a chance in hiring me without having seen me implement anything big deal in my PhD days and so on. So Jim had left IBM just a little over a year ago before I came on board. So I continued the work he'd been doing on some two-phase commit related stuff. So that piece of work actually at the very beginning itself gave me a lot of credibility because I didn't take at face value the advice of senior guy who was there, Bruce Lindsay, who thought that Presume the bot was not as good as Presume Comet. He had only looked at the messaging costs of these two based on variations. I said, look, I'm not going to take your word at face value. I have to actually look at the logging aspects of the protocols, and there wasn't anything out there that clearly was spelled out when to write log records and which of those log records, as you write them, have to be put on persistent storage and see that. So that early on way of questioning somebody just making an assertion and wanting you to listen to them without giving enough justification was a good lesson for me, because later on during the Aries work also the same sort of thing happened. And putting up with such things and still, trying to disprove the person's assertion or whatever, or at least elaborate on the person's claim and see whether it's valid or not, was a good lesson to learn. And subsequently, this piece of work that I did, which gave me a couple of ODC papers, Principles of Distributed Computing, ACM Todd's Transactional Database System paper and such, I became well known from that perspective because it got widely adopted in a practical way, and also it became part of a standard, XOpenXA standard, etc. But at IBM, to commercialize it, it took much more effort because they had a much more general notion of distributed computing than the very hierarchical way in which database systems in a distributed way executed transactions and such. I won't get into the details, obviously. But the environment I was working in was such that, unlike in a lot of the Asian countries, India, China, wherever, where the notion of a technical ladder hasn't been that well thought of. Whereas in the US, there were any number of people around me who had accomplished a lot by staying technical forever and things like that. They might have taken up management, but not in a dramatic way. They might have become first line manager. Like I believe Ted Cord didn't go beyond first level manager. When I came in, he was working on a project adding a natural language interface to System R, broadly a Woo project. And there were others, even people like John Backus, father of Fortran and functional programming. He was in my lab. Some of these people moved from P.J. Watson Research Center to my lab before I joined. Even Cord moved from Yorktomics. Even Don Chamberlain moved from there and so on. Nick Pippinger, well-known guy, right? The extension of NP completeness. I mean, the complexity of algorithms. There's a next class that he defined for parallel algorithms, which was an extension of what was done for sequential algorithms before. So because of the existence of these sort of people around me, I didn't have to be formally told about, this kind of career versus that kind of career. I met them at lunch and coffee time and this and that. Whereas when I moved to India to try to increase the awareness of technical careers and all that, I had to actually formally give presentations to people because they didn't have enough of the senior technical people in their midst. They only saw what society said or your neighbors said. How come your son hasn't become a manager? This other one son became a manager 2 years after he or she joined the company. And they all think, the evaluation of a person's worth is to look at how many people are reporting to that person, how much budget they control. They don't give a damn about how many algorithms they invented or how many papers they published or what kind of impact they had on other people's systems and algorithms and such things. So it's, anyway, that's the sort of luxury I had. But now coming to the Aries algorithm, how it came about and such, at the end of the RStar project, a new project was formed called Starburst, whose aim at that time was to focus on extensible database systems and client-server architectures, because that was the change that was going on then from mainframes to smaller machines and more smarter client machines rather than just a dumb terminal, what we used to call green screen terminals, to having PCs and they connect to servers and how to reduce the traffic between the server and the client machine and so on. And also there were projects around in universities and such, Exodus in Wisconsin and such, that we're looking at how to more flexibly design database systems so that it can add support for more data types and operators and so on without having to do a major surgery on the system. If you compare it with how System R was done, the internals of System R were highly inconvenient to do these sorts of extensions. And so we decided we should have a new project which benefits from all the stuff that had gone on before, not just at IBM, even stuff that had happened elsewhere, both on the research side as well as product side. And so I said, wow, this is a nice opportunity, once in a lifetime kind of opportunity for somebody like me. So I'm going to go revisit what all were the conclusions of the original System R people with respect to transaction-related topics, concurrency, control, recovery, and such. So that's when I realized, the commercial version of the System R stuff in the mainframe was stuck with page locking, even though System R had record locking, but they used a different recovery technology called shadow paging, which had lots of negative things associated with it. And so at the end of the System R project, Jim Gray and other people who were the leaders of that project had concluded write-ahead logging is the right approach. It wasn't like that was something that they invented. It was even being used in the pre-relational system called IMS, which is a hierarchical database system. But it had other characteristics which made it a bit painful. The way storage management was handled, the way locking was associated with byte ranges of physical memory or address space, rather than logically being associated with records and having the ability to move records around without having to lock or log the movements, was the kind of negative stuff which resulted in some painful reorg things which were disruptive in terms of how the impact they had on concurrent activities and such, were taken care of nicely in System R, but using shadow paging. So we wanted the best of both worlds, have more flexible storage management, logging and locking, but at the granularity of record orientation, and also with the write-ahead logging approach, which means you do in-place update rather than whenever you update something, write it to a different location, which is the sort of thing that's been happening with much more modern day stuff like append-only storage and such that's associated with Hadoop and more modern day systems, which has lots of negatives actually. Not enough people recognize them. And I've gone around giving talks on, big data, hyphen reality, where I talked about the pains associated with LSM tree kind of way of doing things. But I won't get into that now. So I decided, even though some people in the project said, what the heck, this is not the aim of the project, reanalyzing or revisiting concurrency and recovery topics. We are only supposed to look at extensibility from operators and such viewpoint operations, and also client server. I said, I don't care. After all, a research project, you might think in a workstation environment, which was the focus of this project, who cares about fine granularity locking or so and so on. But I said, this is a golden opportunity and I'm going to look at things. And also the attitude was, who do you think you are that the big name people had tried before and they failed in this space? Why do you think you're going to succeed? Maybe you should shut up and go do what we think, as a more senior people, the right things to focus on. So here again, I had to sort of resist these sorts of people and their assertions, in spite of how loud they might say such things, and plod along. But I had to invest a lot of time. This is important to keep in mind. Too many of the modern day attitude is, how can I quickly get a return on my investment? I want to, work for a few months and then produce a paper, get name, fame, and move on to the next thing and so on. Some work requires dedicated, longer term commitment and focus and such, where in the initial stages, you might not have a whole lot to show for your progress. And so even the people around you have to have the maturity to allow that kind of exploration to go on, especially in a research environment. You are not in a product environment. situation. And so anyway, I got lucky and turned out I could solve the problem that these other people thought was not solvable with some variation on what the recovery approach was in DB2 on the mainframe. And I spent time interacting with the product guys, the chief architect of the DB2 mainframe product and such, to learn what their concerns were with how Systema did its thing and what pains they were facing with only page locking and so on and so on. Here is another place where coming up with something brand new, while it might be tempting to do that with starting the clean slate and all that, ultimately, if this technology needs to get into a pre-existing product, that takes a lot more effort because you can't just dump the pre-existing product and replace it with a new product, or do things like what Microsoft SQL Server guys did, which was when they went from page locking version of SQL Server to record locking version, where they actually exploited the Aries recovery technology. They said, to hell with the existing customers, there's not a whole lot of production usage with large databases being deployed by the earlier releases customers. So we are going to say, if you want record locking, you have to first unload all your existing data, install the new release of SQL Server, which, by the way, was dramatically changing the page format and all that of the persistent store version of the database, and then reload all this data. But our marching orders were on the mainframe, customers just want to put up with it. You need to leave the data in place and go from page locking to record locking by just merely changing the version of the software, which meant that I couldn't, in a dramatic way, change the way the data structures were on the persistent store. I was left with 2 bits to play with because these 2 bits were unused in the old version of the database. But at least they were luckily initialized with predictable information, like either both are 0 or both are 1 kind of thing, right? So it's these sorts of how to, not in a revolutionary way, but evolutionary way, introduce new technology into a product that when you think about it and work and accomplish it, that the product people and product management and so on is highly appreciative of it. It will require a lot of investment in time because you have to go through some of the things that might not be well documented and such. In my case, even to figure out what Systema guys did was an enormous amount of work because some very important aspects of that system, index concurrency control, index recovery, and so on, was never documented even internally in the form of videos or internal documents, let alone publishing papers on such things. So, and a lot of the people who did that kind of work were no longer at Appian, so I couldn't even go harass them to find out these things by chatting with them. And so it's those sorts of things that in the end, if you look at the Aries paper, it's very long and probably the longest paper ever published in transaction on database systems, 65 pages or whatever. And it has a lot of information, extremely valuable information that I put a lot of effort into collecting and consolidating in the related work section, which almost nobody bothers to read, and then they reinvent some of the things that were documented there by me, even though the original people who did that work never documented it. All of that will clearly show that I tried to give credit to other people and went over backwards to figure out who did what, when, and so on and how. But ultimately, it's this level of dedication and working with product people and such that caused a lot of good things to come about. So that then became like a nice thing to emulate type of way of working between researchers and product people that resulted in the establishment of this thing called the Database Technology Institute, which then became a role model for some other areas within computer science also. And then, because what I worked on had to do with not just database systems, anywhere where persistent data was being managed, these ideas were applicable. So it became part of some file systems, recoverable file systems, messaging and queuing systems, document management systems, transaction monitors, application servers, that kind of thing. And even a distributed operating system. So not only within IBM, but even in other organizations, whether it's commercial organizations or even right here in Korea, for instance, Kyuyang Wang's KAIST project, he gave me this long winding. I had a short name before. Recently, he sent me a message and said, the formal name is Odysseus DBIR Spatial Tightly Integrated DBMS. It's a mouthful. I just said Cosmos, I think. He said that's only the data manager. This system itself is still as bigger. So if you write to him or talk to him, tell him I gave the full form of it. Also, Microsoft SQL Server, Sybase, and Informix Cloudscape is a Java in-memory database system that came to us through the acquisition of Informix, and the O2 object-oriented database system that came out of France and so on. So the challenges for me were not only, putting up with objections from people within IBM Research in San Jose who said, why are you wasting your time looking at this? And you haven't produced any running code in a while. What's going on, blah, blah, blah. Because it took a while before all this came to a good ending, right? In the sense of an algorithm being figured out and it getting adopted. So in order to make it get adopted, I had to do a lot of marketing. Remember, I've now been a manager, but that doesn't mean I didn't have to do marketing of my work to make it be interesting and useful for others to benefit from, both in the education sense as well as in their own system building to adopt the technology. I'm emphasizing all of this to tell you that don't wait for others to discover you've done some great work, because especially in the Eastern culture, the idea in the old days used to be you sit in your corner, do good work. You shouldn't brag about your work. Other people should, on their own, somehow magically discover you've done good work. And then they should come and glorify what you've done. In the dog eats dog world, especially when you're competing with the Western countries, especially America, they might do a little bit and they make a big deal about it. And you do a big deal, but you don't even make a small deal about it in terms of publicizing it or talking about it. It's not enough for you to convince two people around you, this is the greatest thing since sliced bread. If you're really convinced and it's true, you better show it in the way you communicate that to others, and all that passion should come through. And don't view any of this as bragging. You are actually, putting forth in a convincing way why what you have done is of greater value than what a very casual way of looking at it might reveal. So it's for such reasons that I say soft skills are extremely important. It's not enough to be technically good and very smart and intelligent, blah, 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 but you're unable to communicate such things to others. The way you look at people, waving their hands, whatever, and looking at people in their eye and talking and seeing what their reaction is, and as a result of that changing how you present what you're presenting, or whatever, if they're dozing off, then maybe that's a sign that you're not getting through to them. All of this is important. And and I found it a real problem when I went to India during the time, mid 2006 to early 2009, when I was IBM India chief scientist. Any number of people, it's not like their English is bad, it's just that the way they communicate wasn't good. And so I had to now harass people about why that's also important. It's not for you to ultimately succeed or your ideas to take hold. There's a lot of work on that side too, not just on doing the pure technical work. So that includes, papers getting rejected and then having to go argue with people and tell them, hey, you think it's a solved area? Because people thought, oh, Phil Bernstein and a couple of others have written a book on recovery in database systems. That means it's a solved problem. The latest buzz thing is to work on XML or multimedia data types being supported by database systems, and on and on and on. And then in a sheep mentality way, everybody says, oh, this is the in thing to work on, so I'm also going to join the gang. Leaving aside a whole bunch of interesting problems that had not even been solved, but people happily assumed that they had been solved because they didn't spend enough effort digging into that stuff to discover what's actually been done, what's not been done. Brazilian papers were written on concurrency control for index structures. And all of them assume single action transactions, insert, delete, lookup key. I'm like, what the heck? Transactions have many such operations. So if you can't handle multi-action transactions, this is all bogus. Or you do something that even Stonebreaker system, Postgres, assumed transactions either commit or abort, and every action within the transaction will do the same thing. That's not true. There are concepts like partial rollback. A single statement, if it runs into problem, unique key violation, whatever, you would have to undo that partially executed statement's effects on the database without rolling back the whole transaction, come back to the application and say, hey, here is the error, what do you want to do? It might go on and do more things and then commit the transaction, or it might roll back the whole transaction at that point. All of that needs to be supported. This is a requirement of the SQL standard too. So I then was able to go across the world and to different parts of IBM. I was helped in all this by Don Adderley, the chief architect of DB2, who said, hey, they want higher concurrency than what DB2 can provide. So extend Aries to handle messaging semantics, means retrieve a message or dump a message into the message queue without the endpoints of the message queue, where you add a message or remove a message from becoming hotspots, things like that, you know. And then when we acquired Lotus, which by the way is the world's first semi-structured document database system, not MongoDB, not CouchDB, and so on. Those guys were inspired by what Lotus Notes did. Late '89, they had already disconnected operation, field level encryption and authorization, much fancier stuff, replication, even in a disconnected way, and then finding out that when you reconnect, conflicting updates got done and so on, long before relational systems introduced that functionality. Forms-based workflows and such were there, but they also had lots of negative things, which was they thought in a small work group environment kind of way. So the whole database was in a single file, and it was a mishmash of data structures which were all scattered across the file. So lots of things like that were painful later on when the system got widely adopted. So scalability had to be dramatically improved. There was way too much of simple-minded thinking. So this again happens in many environments. Keep it simple and stupid. For every very new set of requirements, new meaning, a lot of old requirements, but one twist on some old requirement. People now find it fashionable to build yet another DBMS. The proliferation of database system in the form of NoSQL systems and so on, with no compatible APIs and all that. So this idea that one system doesn't fit all, that Stonebreaker and others talked about, has been used as a license for everybody and his uncle to go cook up yet another system and such. And this has happened even in social media companies like Google and Facebook and such. This cannot be, in a long-term sense, maintained as new hardware technologies and software things come up. So you do need to, first of all, document your code nicely, and so that other people can figure out what it does, what it doesn't do, and make changes to it, rather than this new group or new person going and doing something totally different, and totally different in the sense of a code base. A lot of the functionality will still be the same as what somebody else did. But this person also, as a result, does a quick and dirty job, doesn't document properly what was done, things like that. So this is a longer talk than what I intended to mention here, but anyway, so there are lessons to be learned from some of these sorts of things. Not all the projects were successful by whatever definition of success you might have. Commercial adoption, research community picking it up, or a sense of satisfaction you get about your stuff going somewhere, not just papers being written, but in a practical sense, it's not having longevity, things like that, right? So later on also, there were a bunch of projects on non-volatile, byte addressable persistent memory, which has become fashionable, but looks like recently Intel gave up on its such technology. Worked on not just transaction stuff, I've worked on query processing things also, in the columnar version of DB2, much more recently, a HTAP version of that columnar version, which not only does analytics well, but also a combination of OLTP and analytics in the same database, as opposed to having a OLTP store and periodically data getting extracted out of it and put in a warehouse, and then analytics being done on slightly out of it. So, also the blockchain space, I got dragged into it in late 2016 because none of the real database people in IBM were looking at what was being done by primarily distributed systems and application server kind of people, the WebSphere type of people. And so I both my nose, and that's when I became an evangelist for the permissioned blockchain systems, as opposed to all this, in my opinion, nonsense that's going on with permissionless Bitcoin and Ethereum and Algorand and various things, which has become like a cottage industry for papers and fly-by-night companies in Silicon Valley and VCs and so on, who are out to make a killing by hyping up all this cryptocurrencies and decentralized finance and all sorts of stuff. I have presentations, so if you go to that spreadsheet I referred to, you'll find links to lots of videos, and I even gave a keynote at Sigmore in 2019 on some of that stuff. So yeah, lots of good things happen, thanks to also my well-wishers and so on, who put me up for various awards and honors like National Academy of Engineering membership in India, US, and such. But notice the last bullet here. It's not that you have to become a manager and some management executive before you become visible. At least in my case, during the last 6 months of my India assignment as the IBM India chief scientist, I was having as the second line manager of mine, my manager's manager, the CEO of IBM. I was reporting to the head of the IBM research division. So that's $100 billion company CEO, not a $1 million company CEO. So depending on your company's or your organization's view of how to reward people and the culture in that sense, and the societal culture, anything is possible. Don't go by traditional ways in which people get evaluated and viewed as being successful. Ultimately, in your own career, what you want to do is highly dependent on what your notion of success is, what you want to see as the legacy you leave behind. Is it, $1 billion in your bank account, or is it ideas and such that you develop that have been adopted by others? Forming a company and giving employment would also be considered a big success if that's the thing that turns you on. But no one other than yourself can make such calls, is the important point. And also, it's not like once you decide something, it's going to be there forever as the only thing you can work on. You can change your mind. There are any number of IBM fellows who have been both managers and technical people. So even Laura Haas and Amit Paresh and people like that fit that category. Pat Salindo, she became a fourth line manager before she became an IBM fellow, right? In terms of summary, this is my sort of take home message. Don't always go with the flow and, like following the Pied Piper kind of way of deciding what to do at any given time, or even in a longer term sense. Oh, my classmate chose to go into industry, so I'm also going to go industry, or this person decided to become an entrepreneur. That means that I should also do the same thing. But think on your own. Carefully, analyze the pros and cons. Do you have the same personality as that person? There are any number of people who, for the reason I stated before, choose to get into management. So that can have a double whammy. You lose a good techie and you get a lousy manager because this person, personality wise, is not management material. He or she doesn't care for how to nurture other people to perform better and how to give them the bad news support, why they got no salary increment because they didn't do a good job or whatever it is. You have to be able to communicate the good news as well as the bad news. If you're incapable of doing that, you don't have the psychological, wherewithal, better not take up management. So don't go for it because in the eyes of some other people, that's considered a sign of success. Questioning senior colleague conclusions, I already told you how in my own life that came in handy. Even industry people should publish more. Don't think of publishing as a way of you're giving away the secrets. Actually, a lot of times it's when you get up on stage and have to explain something, you realize how little you understood of that thing. When you're listening to other people or whatever, or reading some paper, you think you understood very well. You try to give a 2-minute summary of that thing is when you say, oh shit, I'm not so sure now, blah, blah, blah. So that's when you will come to terms with how little of it, even at the highest level, you have understood. So in that sense, you will see the problems in your approach or algorithm or whatever when you try to put it in a concise way in a paper or even a presentation for that matter. A lot of product people give some lame excuse not to do these kinds of external presentations and such, even ignoring the internal presentations, because they think that the rest of the world is going to benefit from their wisdom and this and that. But in fact, the bugs in their way of thinking and all that might come out even with one presentation. So, and also, be willing to give credit to other people. Doing stuff jointly with others can lead to better algorithms and in various ways improved outcomes. But sometimes we get carried away, right? Who's going to be the first author? And I want to get credit as a sole author for this paper. And so what you come out with might not necessarily be the best possible compared to working with others. And in the technology transfer case, researchers thinking that they're somehow next to God or something because they have a PhD, whereas the product guys don't have it. And hence they'll work on something and bring it to a certain level and then throw it over the wall and expect the product guys to do the rest of the work to make it become real is not the most ideal way of doing technology transfer. If you engage with them early on, your algorithms could be better, but also now they have a skin in the game. So they'll be eager to also make your thing become successful. And on and on. So it's also useful to every now and then switch topics. Don't always be polishing a wrong ball by doing incremental work that might not really be all that useful, and you are ignoring something more dramatic that could be accomplished. You are barking up the wrong tree and not solving what are really the problems in even within Caribbean area. Guy Lohmann says, oh, any number of people might be trying to make the cost model become better, then in fact the improvement there might not be as beneficial as making cardinality estimates in query processing be better, because cardinality estimates being wrong would result in orders of magnitude worse performance than the similar kind of mistakes in the modeling of costs. So this was the slide I showed on the last day when I was retired in June 30th, 2020. This is a famous logo of IBM. Of course, it didn't have my face there, but the letter M was there, right? Just the letter M. So it was kind of cute that M for Mohan suits my putting my face there, and also the fact that I had worked for about 1/3 of IBM's own life at IBM. It's about 100+ year company, and my 38.5 years amounts to about that much. So I said, I deserve one letter of this logo, and I stuck my face there. Clearly, I had an environment where I got lots of benefits, but then few weeks later, got invited by that Microsoft fellow to consider working for them as a consultant. So it was a short one, so I'll let you read these things subsequently. the jokes that are out there about consultants and how they recommend and so on. But I was also, for the first time, going to be getting an inside view of some other company systems. And also, I'd been ignoring the hardcore database area for a while in terms of keeping up with what's going on, because I got distracted by the blockchain stuff. So I finally got to see some of the exciting stuff that had even been published in the last few years by the Microsoft people. And it was very heartwarming for me as a hardcore database guy to see so much investment was still being made, whereas at IBM, they had sort of more or less given up and gotten hooked on to hyping up, blockchains to some extent, even that they have stopped now. But more importantly, cloud, quantum computing, and AI have become the, things that will turn on the execs and give you attention and so on, right? We'll let them give you attention. Whereas I'm finding out even more recently with the work I've done at Google, that there's exciting stuff going on at Google and Amazon and Microsoft. Not necessarily all of them are spending a good amount of money on research in the topic, but even product people are doing some innovative stuff in terms of new systems and new algorithms and new aspects to existing systems, things like that. So that has been a very satisfying way of continuing to keep myself engaged technically. So when I was retiring, I said, I'm not retiring from doing technical work, I'm only retiring from IBM, and I hope to continue to work in a part-time way, not take up a full-time job and get a regular kind of money. And beyond a certain point, money itself is not the most important thing in life. Yeah, you need a certain minimum amount of money for a good lifestyle and such, depending on your interest again. I'm not the kind of guy who is going to sit there and meditate and feel good, and that's all my notion of happiness is. I do want to travel and eat, drink or whatever, and do certain things for which I need some amount of money, but I'm not trying to compete with Larry Ellison by doing sailboat racing with him and that sort of thing, right? Which is what the SAP, one of the founders, was doing with Ellison, even though they were competitors, they were, I mean, not just in the money-making sense and the company products and so on, but they were also competing with respect to sailboat racing. So these are the sorts of things that Bhushan also talked about that I'm engaged in. So it's a mix of trying to do good stuff. For the first time, I became a board of honors member of a pre-existing institution that had been turned into a university in the state of Kerala, next to my state, Tamil Nadu in India, South India. And so that gives me visibility to different sorts of things that I wasn't aware of. And also I was a Shah visiting professor at NUS in the first half of last year. For the first time, I was responsible for a course, not a regular course, but a seminar course. Still, I had never done that sort of thing, right? I'd been invited to teach a course at Stanford and so on by Hector, but I said, no, that's too much work, a regular course, preparing everything and so on. So I never, even as a PhD student, handled a course beyond one semester being forced to be a TA just because my professor ran out of money for research assistantship. But that was just like tutoring, not actually delivering the course lectures. So I had to discuss assignments and such. So I'm also continuing to do things like industry track co-chair for this year's VLDB. And I invited people to give talks and also organized a panel discussion on database researchers who have founded companies. And so things like that keep me out of trouble from my wife. I stay away from her and go spend time these days at Google. And so while she continues to write her books and articles and blogs and such. So that's it. Thank you for your patience. Any questions, comments? By the way, some of you have listened to this talk, of course, so you might have noticed with the same set of slides. Currently, I'm saying not necessarily exactly the same thing I said the other day in, Fukuoka. Yeah,
I have a question.
yeah, why don't you use the microphone?
First of all, thanks for your wonderful talk. And I'm Oki from Data Systems Lab.
Sorry, yeah, that's.
Yeah. In recent years, hundreds of thousands of papers have been submitted and tens of thousands of papers have been accepted as AI conferences.
Yeah, yeah, it's okay.
And so many.
Maybe if you keep moving your head, it goes.
And so many AI researchers here. As a computer science researcher, I want to ask you, how do you think of this overheated AI society? And furthermore, I wonder your opinion of the future of AI technology.
Oh, this is an easy one to answer. I'm just going to say, go look into that spreadsheet. Because I've given a bunch of talks on this topic, titled Artificial Intelligence, Past, Present, and Future. So even though I'm not an expert in the topic, it happened that in April 2017, I was asked to go to Hong Kong to give a talk on AI in the enterprise. I'm like, hey, you're asking the wrong guy. It turned out all the other people who were senior people in the AI space in IBM were busy and they couldn't go. So I said, like sticking your neck out, okay, this is a chance for me to, even though I tracked stuff that had happened while I was sitting in India during my undergraduate days, MySIN and various things, speech understanding and CMU and so on. Stanford Research Institute, people were doing image processing using AI concepts, things like production rule systems and such. So I said, okay, let me go get the slides from the IBM guys, IBM's perspective on AI and so on. So, which as you can imagine, happened to be on, let's get beyond just social media and e-commerce kinds of use cases, where you have tons of data available to train the systems and such and build models. And also the latest hoopla with this black box approach, which is a born again kind of neural net, which is deep learning, right? Just shove some stuff and out comes the answer. Is it a cat or a dog? And that's the most important problem in life to be dealt with, right? So if you go look at that presentation, you will see stuff like this being talked about as to why, explainability and bias and all these sorts of things, and also being able to do things with small amounts of data, training data, and then adaptation as data changes also. How the model evolves and so on, how to treat that model itself as a thing that needs to be carefully dealt with in the same sense as software engineering has all these ways of tracking the evolution of the software, similar to schema evolution, database systems. You have to deal with the models also carefully. And you will see that, the symbolic way in which AI systems used to work in the days of speech understanding and such, where they would model the syntax and semantics and phonetics, in addition to possibly some statistics-based way of doing things, is still important, because that's what will let you say, if you conclude that somebody doesn't deserve a loan, what is it that they didn't have as one of the requirements that caused this decision to be made? You can't just say, hey, delete this box, which is a black box, which is doing the algorithmic determination, because they can sue you for discrimination and so on. So yeah, there is way too much hype. And as I said earlier in the talk itself, some people naively think this is all some brand new thing. It's actually gone through many such ups and downs. It's more than 50-year-old technology, AI, and the way in which it's been explored in the past and why it failed and so on. So don't get too carried away by some of the claims made by these social media kind of companies and their people and so on. So if you go and look at that presentation, I've given it a few times and there are videos of this particular presentation. I would have been more than happy to give it here also. There are various sources of information that you should look at. There's an excellent report, and I have lots of links by the way in that presentation. Just like in this one, I didn't have really seriously any links, but in all my other more technical presentations, you will see links to relevant papers and such. So the Stanford has an institute in this space. I forgot the exact name now. They put out an annual report where they actually give you some high-level changes or patterns that they see. How many people are doing research in AI, undergrads and masters and so on, where the funding is coming from, which are the companies that are important companies, what are the use cases that are being explored and such. So it's these sorts of things that will be very valuable to look at. And also, in the West at least, too often they're just looking at their own neighbor. What is going on in Silicon Valley is all that matters or something. The Chinese companies are working here crazy, publishing papers, producing products, and so on. And so in that sense also, the different geographies focus on different things. So I have information on the strategies of the different countries. Singapore, for instance, focuses on shipping, where it's one of the most important ports in the world, right? So the AI focus use case areas also change from geography to geography based on their own problems and such, or the kind of expertise they have, or the kind of GDP generating activities that go on in that place. There is lots of unsolved problems here. Like I said, sometimes people get carried away with looking at pictures of cats as if that's the most important problem to be solved. Benchmarks have their own negative source. They too often focus on not necessarily the most important real life problem. This is true of even PCC and such. Right? So that's why it's important to work with real customers and their problems and workloads that matter to them. That was a long answer. Any other questions, comments? I don't know how much time you can decide.
We don't have time, but just one more question if you have.
Some of you, of course, I'll be meeting you separately also, so you can bring up the questions.
Hello, I'm Jigyam, also from Data System. When I learned my database, my professor told me that in real life you can't just use the data structures or implementations that you did in the academics. So I want you to give me some examples and differences of real life implementations and like you did in IBM, different from some academic implementation.
Well, I mean, I in a sense said that by pointing out that incorporating some ideas into an existing product is not as simple as putting it into a brand new system. In my case, Aries got incorporated straight away in the first version of the OS2 Extended Edition Database Manager because they were in the process of developing it, and these were actually non-database people that were tasked with doing this in Austin, Texas. So we essentially were able to influence them from day one. But like I gave the example, in the case of mainframe, it was a much longer, if you look at the slides, the details are there. It took many more years to introduce this technology. And, so there are many such situations where upward compatibility requirements, or you are stuck with some existing data structures, persistent store structures that you can't just willy-nilly change. You can create others, but then those will be there for the newer tables you create or whatever. Just like when column store was introduced, IBM's DB2 introduced that as an alternate data manager. It tried to benefit as much as possible from the existing row-oriented data managers, buffer management and this and that, logging and so on. But there were still certain things that were done differently. And so this way of doing things is better than just forgetting the old thing and then now writing from scratch. Following it. So yeah, there will still be situations where doing something brand new will get you a whole bunch of benefits and such, but be aware that in the process, you are screwing up people. Jim Gray, for instance, used to say, oh, look at the tandem manuals. They are A thick, whereas the IBM manuals are A thick. Guess what? By the time he left tandem, their manuals became bigger. So if you didn't have a history to deal with, you can, yeah, get away with all sorts of stuff. But after a bit, if you are caring about your customers, you do have to think about, you know, even in System R, for example, the SQL had some nonsense in it. Especially with the way nulls were handled. Later on, when the standard was developed, some of that got fixed. But in the meantime, the customers of the System R's product version were not depending, but they had built stuff knowing what the weirdnesses were, right? We couldn't tell them, hey, now that the new version of DB2 is supporting standard version of SQL, you have to go rewrite your applications to now adhere to whatever these things restrictions are. So we had to continue to support the old semantics or whatever syntax and so on, as well as the new one. And so every now and then you'll have these buttons or knobs that you tweak to say, compile it with this set of functionality or that set of functionality. Yeah, we can have a longer conversation about this, maybe more specific data structures.
Okay, thank you very much. It's very